sample of both sides, but I wouldn't bet on it. Okay, I just got a chunk of that side.
They have what I consider one of the most important.
Can you talk about kind of what went into your sampling strategy and how you chose which samples to bring back?
The idea was to get as broad a spectrum of new samples as we possibly could, and that turned out pretty well. We did. And in fact, we sampled at least ejecta, melt, what we call melt ejecta from 3 major basins, maybe 4. We sampled fragments that almost certainly came from the deep mantle of the moon. We didn't know that at the time. That's only recently that we figured that out. And that we also then added to our broad knowledge and history of these volcanic eruptions that have occurred on the moon over time. Now when you go to the moon on the way to Mars, Jessica, that education I think you're going to get on the moon will be very relevant to Mars. But Mars, of course, does not have that micrometeorite impact environment that we have on the moon, because it has a small atmosphere, about 1/100th of that of the Earth, and that filters out the small impact. The main weathering process on the moon are these micrometeorite impacts and solar wind spallation of the surface. Solar wind's made up of high energy particles, so they actually erode the surfaces of rocks as well as change the character of the debris layer on the moon. On Mars, the dominant erosive force is wind.
Yep.
And so if you're used to studying geomorphology here on Earth that involves wind,
you're in good shape. Yeah.
You can learn a lot about what you're going to see on Mars. But all of that comes from studying the moon.
Right.
If we hadn't had the moon, we wouldn't understand this early history of the Earth, or even speculate about what it might be, speculate intelligently anyway, about what it might be.